Hi, we're doing the calculator portion of section 1.6, BC Calculus, Taylor and Shaw. We will show you how to do derivatives on the TI Nspire. Now there's a couple ways to do them. One, you can just go to a regular doc, calculator mode, and with this you can go to menu, and there's a calculus, and then there's a derivative at a point. So if I take and I can do the variable x, and then I can do this at the point. If you look over here, it says f prime of 2, so I'm going to do it at 2. It's going to set me up, and then I'm going to take the derivative of x raised to the third. I'm going to go right arrow, and then plus 3 raised to the x. And I want to evaluate that at x equal to 2. This little bar here is evaluate. You also can get that by going to control and the equal sign, and that will give you the bar, and you can evaluate anything by plugging that in. So then that would be the answer that I do get. I want the approximate to see if I get the same answers over here to the right. 21.887. There it is. If you rounded, 888. So that's how you can find the derivative at a point. Another way is you can go to the menu here, and then they do have the derivative, second derivative, and so on. That gives it to you straight away with respect to x, and then I can do that same function that I have here, type it in, and then if I want to evaluate it at something, I can go to what I just showed you, control equals, and then here's the evaluate button, and then I got x equal to 2. That should give you the same thing. So that's how you can do that evaluation at a point. I can also do it if I graph this. So here's my function, and then if I go to 2, it's like right about here, so then I can find my slope in here by going to the menu and then analyze graph. It's just like you're finding a max or min, and then you can go ahead and find dy dx. And then what position? You just type in now the number that you wanted, which would be 2, and there it is. If you don't have enough decimal places, you can hover over it and push the plus symbol. That will give you more decimal places. Or you can fix your decimal places to 4 decimal places. So that's what you can do there. Now, what's nice on the graph, good or bad, you don't know the exact x value anymore, but you can slide it and get an idea of what the slope is at different values. Now, looking at number 20 here, we can go ahead and find g prime of 2, g prime of 4, and sketch a graph of g prime. So there's different ways to do this, but let's try to, first of all, if I have the graph here, I can go to the menu, and I can go analyze graph, and I can find the dy dx. And then my position here at 2, if I put 2 in there, just type in the number 2 and you should get out a 4. Now I can estimate this next one to get to 4, but I can't get it exact unless if I just go ahead and do this again. So I analyze the graph, and then I find dy dx. Position would be, I type in the number 4, and then I get 0.615. That would be my answer. I was close on my other one, but not quite. 0.615. So that matches up with that. Then if you want to graph the derivative, I can get into this one and go to F2. And with F2, what I want to do is just go menu. I'm sorry, I don't want to do menu. I want to do this one here and go the derivative. And with respect to x, I can just type in now f1 of x. My typing isn't so good. And that should show me the graph. And that's the graph that I do get. If you notice, we do get an error in here. this function right here, ln of x squared minus 3, is not defined between negative square root of 3 and positive square root of 3. I don't know why we're getting this weird one in the middle, but the graph is actually just this outer boundary and then this other boundary as descripted here. So that's what we end up with. I'm not sure why it gets in there. Now if you do number 21, you can graph that and then tell us what f prime is. For absolute value, you can just type in ABS. Otherwise, you could have gone here and there should be a absolute value symbol. There it is. You can do that one right there, but I like to just type in ABS. And there's my function. Look at my derivative. My derivative is still this thing left over here in the red. And you notice that there's a big jump in the derivative. Well, that tells me that the limit from the left side derivative and the limit from the right side derivative are not the same. So right here at x equal to 0, we do not get a derivative. Yeah, we have a derivative over here. Yeah, we have a derivative over here, but not at 0. And then the graph bears that out. Now, if I want to figure out what is the derivative at that point, I can just type in my f2, because I do have f2, and type in 0, and it says plus or minus 1. Wow, that's a little bit of an error, but it's saying from the right I got positive 1, from the left I'm getting negative 1, but when we come together, I can't have a kind of a continuous function approaching one specific number. So then the derivative does not exist at 0. Well, I just came up with 2 examples that contradicted some of this stuff over here, but this is all right over here. So you got to be careful with the calculator. Sometimes it tells you too much or not exactly the right information, extraneous information. I hope this helps, gives you an idea how to find derivatives with the calculator. There are other ways too, but these are just a couple. Thanks.